Hey guys, today we're gonna build this neat little audio visualization in JavaScript. It's showing the waveform of your microphone input in real time, like an oscilloscope. Let's dive right in.
Banana.
I already prepared the bare minimum for you, so you got the HTML page with a canvas on it to draw that waveform, and then we got a button to start the microphone input. That will also trigger a little dialog and ask you for permission to use the microphone later on. But as it is, it looks the very same as you saw in the intro. The button is just non-functional, and that is because the script is completely empty. So let's dive right in and implement that. The very first thing we're going to do is grab the canvas to later be able to draw on it. We're gonna use getById and grab the ID waveform here for the canvas. Then for drawing, we need a context. That's basically the API to interact with the canvas. I'm going to draw on 2D, so I'm going to go like this. And furthermore, we need the button that we defined, so the start button. Okay, and now we're going to hook a click listener to that start button. So we're at event listener, click, and that gets a function to execute on click, which will set up the microphone for us. Like this. I like to define the functions first to see how the program will look in the end. Once the microphone is set up, we want to alter the text of the start button to something like stop microphone. Yeah. So it changes from start microphone to stop microphone on click. And then of course we want to draw the waveform. Let's define that function down here as well. Now we want to get microphone access. For that, we're gonna prompt the user using the navigator API. So we wanna have a microphone stream, and use the navigator API to ask the user for permission to their media devices with get user media, and we specify what we want. We want audio here. Then we're gonna define an audio context. Audio context. Call that constructor here, and that audio context is basically the audio graph of the web audio API. You can define inputs and outputs and processing steps in like a graph fashion. You will see that in a second. Let me first add that async here to the function. This will also need an await up here, so we're gonna wait until access is granted here. And once we have that audio context, we can also get a hold of the microphone input node, basically, right, of this graph that I just talked about. Can get that via the audio context. Create media stream source. And we pass that stream that we requested. And yeah, next to the microphone input node, we are going to have a so-called analyzer node that basically grants us access to the individual amplitudes of the audio that's going to the microphone. So we're going to use that audio context again to create an analyzer node here. And then last but not least, we're gonna connect the microphone, like in this graph fashion, right? We're gonna connect the microphone node to the analyzer node. Okay, now that we got microphone access, we should also introduce some teardown logic to remove the microphone access once we're done, once the user clicks that button to stop the microphone again. So if we don't have an audio context yet, we wanna like set up the microphone, change the text and draw the waveform. Else we're gonna stop microphone. Let's define that function down here as well. Stop microphone, there it is. And to check that audio context, that of course needs to be a variable in the scope, like so. Okay, now let's implement the actual teardown logic. So if we have a microphone node somewhere, right, that input node that we just created, we want to disconnect it from that audio graph. And additionally, we're going to set this to null, so our if condition here does actually check something. And we're going to do the same for the audio context. If we have an audio context, we're going to close that and likewise set this to null. For accessing the microphone here, we still need to move it to this scope, not microscope, microphone. Okay, now we got that teardown. We also want a function to reset that canvas, right, for the next run, whatever. Okay, we're going to implement that once we know how to draw the actual waveform up. Forgot the function specifier here. Okay, now comes the actual fun part, implementing drawing the waveform. For that, we want to get the amplitudes from the analyzer. For that, we will need to know how long such a buffer is, right? Frequency bin count. So the analyzer gets the audio in chunks that are called bins, and this is basically the length of those lists that it has. Then we're gonna have a data array for storing those values. Like, we need to write them somewhere. We can't use them directly from the analyzer, and that will be an unsigned integer 8-bit array. So that means this is numbers from 0 to 255. That's going to be important in a minute. And then we're gonna define a function in a function here. Yeah, long-lived JavaScript. For a recursive draw loop, right? So in here we get the data from the analyzer using get byte time domain data, and we're gonna write that into the data array here. Afterwards, we're gonna prepare the canvas with a fill style of this color here. So that's gonna be our background for the canvas. And then we're gonna have a rect filled, so to actually fill that background in, right? We're gonna define a rectangle, whoops, not the client width, canvas width and canvas height. So to fill the whole canvas, we draw a rectangle of this color. What else? Now we're gonna define the line width for this oscilloscope line that we're gonna draw, and we're gonna define a stroke style, and that's gonna be the same color as the button. Gonna take that from the style sheet here that I prepared earlier. And once we got that, we can begin a new path on the canvas. Now we'll basically start drawing for us. So where do we draw? We're gonna split the canvas width into slices. Yeah, as many slices as this buffer contains amplitudes for the audio. And in each slice, we're gonna draw one point basically of that line that you'll see in the end. So we are gonna have a slice width, which is the canvas width divided by that buffer length that we had up there from the analyzer node. And now we're gonna create a loop. So we need X and Y coordinates to draw that line, right? So we start on the very left of the canvas, X equals 0. And then we're gonna implement a for loop starting with 0 and going to buffer length. And in there, we're gonna normalize that data that we get. So earlier I said that's an unsigned integer, values from 0 to 255. So we're gonna normalize that to 0 to 2 values. So maximum being 2, minimum being 0. You will see in a second why we're gonna do that. So we take that data array value, little typo, we're gonna divide that here, and then we normalize that to the actual canvas size. So we're gonna take that value between 0 and 2 and multiply that by the canvas height, and we divide that by 2, and that brings us to values between 0 and the canvas height, right? So we use the overall space of the canvas now, and now we're gonna use the context 2D API again. So for the very first step, like the very first iteration per buffer, it's gonna we're gonna move the pencil, so to say, that draws it to those XY coordinates to start. And for every other iteration, we're gonna move a line basically, or draw a line to the XY coordinates, right? So we don't want to connect the very last to the very first of the next buffer, so that's why we use move to reinitialize the position, and line 2 will basically draw the actual line. And now we just need to increment X with the slice width. So now we got that for loop done, and once we got the whole line for that slice defined, right, or for that buffer defined, we're gonna call context line 2 canvas width canvas height divided by 2, so we end up in the middle of the right side of the canvas. So that's going to be our last point, and then we apply that thing by calling context stroke. Now we gotta basically loop through the whole thing, and therefore we're gonna call that function again, but not just draw. That's not gonna work. We're gonna request an animation frame like this, like so. And to, yeah, this is just defining the function, right? You see here it's grayish and not used yet, so we're gonna trigger that initially the same way. So we're requesting an animation frame of draw that will run the function, and once that's done drawing, it will call itself to loop basically and create that animation that we want to have. Now let's check if that's actually working. We get to ask for the microphone axis, but we don't see anything. Let me see, analyzer is not defined. Let's see, where's the analyzer? We're using that in the draw function here, and still have that only defined in this scope here. So let's also add the analyzer up here as well and see if that makes a difference. Reload, start microphone, and there's our waveform. Nice, no errors. Gonna close that up. Now as very last step, let's see if we can stop the microphone. You can see it's still keeping the graph from the buffer before. So let's add a little cleanup to reset that. So in here we're gonna cancel our animation frame, and for that we're gonna need a handle, and that's what we get from here. So let's call this animation frame. So each time we request animation frame and run the draw function, we're gonna set a variable here called animation frame, and we're gonna pass that reference in here. So we break that endless loop of the animation. What else? I also saw that this still says stop microphone, so little thing I forgot up here. So whenever we stop the microphone, oops, we want this to say start microphone again. And then we finally want to clear that canvas. We're going to use that context API from the canvas again, and this time we're not going to draw rect but clear rect, and that will also go from 0, 0 to the full canvas width and canvas height. Okay, I think that should be it. Let's see. So once more, we start the microphone, things are working. We stop the microphone, things are cleared. Microphone button is reset. Cool. That works nice. Yeah. Okay, you can play around with it. I'm gonna put a link to the repo, to the code, and a deployed example in the description as last time. Yeah. And if you want to support this, feel free to subscribe to my channel, leave a like, leave a comment on what you want to see next. It would be awesome. See you next time, Bit Bananas.